Alrighty.
I did Angelman syndrome, and Angelman syndrome is a genetic disorder that causes developmental disabilities and nerve-related symptoms. It usually isn't noticeable until about 6 to 12 months of age because that's when you start to notice developmental delays. Around ages 2 to 3, you get seizures. They may also occur on that age. Some symptoms of this disorder are a lack of crawling or babbling, minimal speech, and frequent smiling and laughter in young ages. As you get older, symptoms may be unable to walk, move, balance well, drooling, lazy eye, and seizures. Most cases of Angelman syndrome occur when part of the maternal copy is missing or damaged. In other cases, it is caused when 2 paternal copies of the gene are inherited instead of one from each parent. Some treatments are anti-seizure medication to control the seizures, physical therapy to help with walking and movement problems, communication therapy, which is sign language and picture communication, and behavior therapy to help overcome hyperactivity, a short attention span, and to help in development. The body parts that are affected are mostly physical and speech problems. The people that are affected are about 1 in 10,000 people, however many cases go undiagnosed. This is Lucia. She was in and out of the hospital for months before her parents.
Zoom in a little bit and focus it better for you.
Thank you. This is Lucia. She was in and out of the hospital for months before her parents had a diagnosis. Around 6 months of age, her mom noticed she wasn't normal, but she didn't want to take her yet because she didn't want something to actually be wrong with her baby. At 12 months of age, she had had 2 seizures by then, so the second time they knew something was seriously wrong, and they diagnosed her with Angelman syndrome. They said the speech is the hardest thing to deal with, and now she's 18 months old. She continues to grow and learn, and her newest symptom is seizures.
Very good, thank you. All right. Tyler, you got yours? All right. Samantha, you want to go ahead? Do you need anything? Okay.
Alright, I chose Huntington's disease, and it's a disease that's kind of passed on through the family, and it's a brain disorder that produces physical and mental and emotional changes. The population affected in America is 1 in 10,000, which is spread equally between men and women. People with this disease usually rely on others to take care of them. And the early symptoms start with uncontrollable movements, clumsiness, and stumbling. They also lack emotions and focus, so they struggle with being able to concentrate. Other symptoms are short-term memory and mood swings. The symptoms can start at any age, but is commonly between the ages of 35 to 55 years old, and they only get worse for 10 to 20 years until the person passes away. This disorder is caused hereditarily by defect in a single gene. Only 1 copy of a defective gene is needed to mature the disorder. There are treatments, but these treatments only lessen some of the symptoms in movement and psychiatric disorder. Medications for movement would be tetrabenazine, and for psychiatric disorders would be antidepressants, antipsychotic drugs, and mood stabilizing drugs. There are no other parts of the body affected, just the brain, movement, memory, and mental ability. That's it.
You want this one or this one?
Yeah,
Which one?
the middle one.
Got it?
Takes it. Mine is a progressive disorder. It basically it turns your skin into a pool for calcium and minerals to stock up. And it makes these yellow, small, raised areas in your neck, armpits, and other areas. It can break your retina, or not break, but rip your retina and cause you to go blind. It's obtained through a gene named ABCC6 that makes the protein MRP6. The protein is in your liver, kidney, skin, stomach, blood vessels, and in your eyes. Basically what happens is it doesn't make the protein. The gene doesn't. It's actually pretty rare. The female to male ratio is 2 to 1. It only happens in one case per 25,000 to 100,000. There's a picture. It makes it kind of rough. Like sandpaper, I guess. Yeah, that's it.
What did you call?
I have no idea how to pronounce the first part.
Pseudo?
Pseudo-oxynthoma. Plastic.
Right, yeah. Very good.
Okay. Who is next? Alright. Do you need document camera or anything?
Alright.
Okay. Let me get this off then.
Alexander's disease, it's a neurological disease, and the symptoms are usually found during the first 2 years of age, but it has 3 different forms. It can form in babies, usually also around our age, and usually in later life, adult age. Some of the symptoms include a large brain and head size, seizures, stiffness in the arms and or legs, intellectual disability, and developmental delay. It rarely forms later in life, but the adulthood stage is being found more frequently now. In the adulthood and juvenile stages, it has more symptoms including speech abnormalities, swallowing difficulties, seizures, and poor coordination. Also, a rarely form of Alexander's disease occurs within the first month of life and is associated with severe intellectual disability and developmental delay. A buildup of fluid in the brain and seizures. Alexander's disease isn't a very common trait, as only 500 cases have been reported since its discovery in 1949. It affects the GFAP gene, and this gene is the gene that this disease affects, which makes certain proteins that can The protein makes intermediate filaments, and it's a result of abnormal filaments, and it kind of some the
Intermediate filaments are part of your cytoskeleton. You guys remember that part of the cell that crisscrosses throughout the cell.
and only one trait of this disease or of this mutation is needed for it to kind of show up, but it's unknown how it occurs since it doesn't occur through families, and it's kind of just a random mutation that happens so often. It's 1 in a million. I think it's a million. So 1 in a million. There's a one. It's a 1 to a million ratio of having it, and there's no cure for it. But the only cure for it is to stop the symptoms from happening, and that's including drugs that will stop seizures and control and assessment for learning disabilities and cognitive impairment and physical and occupational therapy.
And was it named after, Alexander's disease? Was it named after the disease that discovered it?
I think so.
All right. Didn't you upload your yesterday? So it's probably up here.
Which means you're next.
Hold on.
Cerebral palsy is a disorder of movement, muscle tone, or posture. Some symptoms are impairment of muscle tone, gross and motor functions, balance, control, coordination, reflexes, and posture. Also, there could be swallowing and feeding difficulties, speech impairment, and poor facial muscle tone. Cerebral palsy is caused by a brain injury or brain malformation that occurs before, during, or immediately after birth while the infant's brain is under development. The brain injury that causes cerebral palsy cannot be healed, but the resulting physical impairment can be managed. Therapy and adaptive equipment are the primary treatment, but some families turn to alternative medicine. The goal is to optimize mobility, control pain, and enhance social skills and quality of life. Cerebral palsy affects about any part of the body. It varies upon severity and combinations of symptoms. It's the most common of all childhood disabilities. Affects about 3 in every 1,000 births. And here's a picture and sources.
All right, ready? All right, and then number 3, or 4, I guess, but I don't think it's here. You're done, Mindy,
I mean, you're here. I just didn't think you were ready to be up here. Eric? Bethany? Kristen? Bethany? Alright, so yours isn't on here.
It isn't, but on the iPhone it is.
Because I don't think that you've even joined my class yet. Nope, you're still invited. You haven't joined yet. So it's on your it's on your Google Drive or whatever. Yeah. Okay. Yep, so you just haven't joined my class. So go into Google, classroom.google.com. Eric, how about you? Then what are you doing right now?
Watching the presentation.
Weren't they due yesterday?
Yes, ma'am.
Christian. Alright.
Yes.
Anybody I'm missing that besides the school here? Is your classroom that new? Okay. Which Steph, you need to, and Savannah, you guys probably also need to join into this Google Classroom deal. No, it doesn't matter. You've already logged in at some class because you changed your profile. So do you remember your password for that?
Yeah, I'll put it on. This is mine.
While you guys are waiting, why don't we go ahead and get out a piece of paper because we're going to do vocab. Too. Open your mouth before it stops. There we go, okay. Still nothing. I thought you borrowed Seth's pen yesterday and then gave it back to him.
I said I would move back. I just want to work.
There's this pencil right here. There we go. Alright, and then go to the next over room, hit open. And then there should be a place to add, go down a little bit there. And then we'll do the brand. Okay. All right, here we go.
Okay, I did mine over depression. It's a mental condition. It has feelings of guilt and lack of energy and disturbance of appetite and sleep. Symptoms is no energy, feeling worthless, not enough sleep or too much sleep, losing hobbies, or eating changes. 50% of it is genetics and then 50% isn't. Um, much of what we know about the genetic influence of clinical depression is based upon research that has been done with identical twins. Identical twins are very helpful to research since they both have the exact same genetic code. It's been found that when one identical twin becomes depressed, the other will also develop the clinical depression approximately 76% of the time. When identical twins are raised apart from each other, they both become depressed about 67% of the time. Because both twins become depressed at such a high rate, the imply is that there is a strong genetic influence. If it happens that one of the twins becomes genetically depressed, the other always develops depression. Then clinical depression would likely be entirely genetic. However, because of the rate of both identical twins developing depression is not closer to 100%, this tells us that there are other things that influence a person valuably to depression. These are including environmental factors such as childhood experience, currently stressors, trauma events, and exposure to substance medical illnesses. What is the causes in genetic and environment? This would mean that in most cases of depression, around 50% of the cases is genetic and around 50 is unrelated to genetics. Treatments are different for everyone. It depends on the stage of depression they are on. Everyone is different. It may take some trials and error to find the treatment plan that works best for you. It also takes time for an antidepressant to have its full effect. You may meet with several doctors or therapists before you find the one that works well. Major depression disorder affects approximately 14.8 million American adults, or about 6.7% of the U.S. population under age 18 and older is in a given year. And that's it.
Is it possible? Yes.
So someone could have autism and visionary side depression.
Yeah, it is possible. It is possible. Very sad, but very possible, yes. Okay. All right, let's go ahead and do some vocab, and then we will come back to you guys.
I might actually finish part of the period.
How many vocab words do you have?
I think there are 15. I have 16 slides, and this is one, so I'm assuming 15. We'll go with that. All right, this chapter is all about DNA and RNA and how we make those proteins. Now, almost all your genetic disorders that you guys talked about were, a certain gene, right? And there was a defect in the gene, or some of them was chromosome number abnormalities and things like that. So this whole chapter is going to be about how the DNA has the code, how that code can, how it's supposed to be, and then how things can go wrong as well. All right. So our first word is called nucleotide. A building block of DNA and RNA consisting of nitrogenous base, a 5-carbon sugar, and a phosphate group. Does anybody know what the structure is right here?
It's a nucleotide.
No. It's DNA. It's a bunch of nucleotides linked together. So a nucleotide is a building block of DNA or RNA. And this is DNA. Does anybody know why this is DNA and not RNA? Just throwing this out here, see what you know. DNA has 2 strands where RNA has only 1. And so we're going to get to that kind of stuff this chapter. But what DNA and RNA are both made up of are things called nucleotides, and there's 3 parts to a nucleotide. There's a phosphate group, a 5-carbon sugar, and a nitrogen base. Phosphate, sugar, base, phosphate, sugar, base, phosphate, sugar, base. Everybody see that? You guys are going to be making keychains at the end of the week, right? And your keychains are going to look like DNA. All right, you guys can probably all see those up there. So anyway, the DNA is made up of nucleotides. And so these are basically the building blocks of them. Mm-hmm.
How's the dangerous? Can I start cutting this into quicker on my phone?
Sure. Okay. The next term is double helix. Double obviously means 2. Helix means twisted around. So DNA is in the shape of what we call a double helix. So it says it resembles a spiral staircase in which the paired bases form the steps and the sugar phosphate backbones form the rails.
Sugar, phosphate, one word, or is it just
2 separate things. Alright, so double helix, this is basically the shape of the DNA. It resembles a spiral staircase. You guys have all seen a spiral staircase before, probably. Or just think of a staircase right now. And you know how you got the handrails on each side? Okay, that would be like the phosphate and the sugar. They're on the side of the DNA. And then the steps would be what we call these nitrogenous bases, these bases that are going to link the 2 sides together. And then just picture the staircase twisting. So it looks like that model up there over on top of that, over the VCR.
The following students in the high school office: Mason Archer, Walker Fidel, Haley Carter, Hunter Floyd, Bradley Foster, Mackie George, Addison Graham, Jessa Howery, Jasper Jackson, Denver Davis, Darius Escalante, Hudson Enos, Zach Childress, and William Dewey.
Okay, so if I go back to this picture right here, you see how the sides here are the phosphate and the sugar, and then the steps would be the bases, okay? And then picture it being twisted like that, okay? So that's what DNA is in the shape of. We call it a double helix. All right, the next term is base pair. And this is what we call a pair of complementary nitrogenous bases in the DNA molecule. a pair of complementary nitrogenous bases in a DNA molecule. So this one should be easy, right? Base pair, a pair of bases. Yeah, anyway, hopefully you get that one. But when they say that they're complementary, what that means is that they go together. So there's 4 bases that are in DNA. They're A and T and G and C. And A and T will always go together, and G and C will always go together. Okay, so if I go back to this picture again, okay, I like this picture because it's simple and it shows you pretty good. See how these are the bases, A and T, and they always pair together. G and C will always pair together. Okay, and so the bases are basically the steps of the ladder there. Okay, and here's that nitrogenous base again. There are 2 different types. There's the purines, which are called adenine and guanine, that's the A and the G, and pyrimidines, which is thymine, cytosine, and uracil, that are going to make up DNA and RNA molecules.
Differences or?
Good. I'm going to go to the library because it wasn't working. So if you look over the classroom,
Teachers and students, have your attention please. We need the following students in the office. Brian Reagan, Spencer Ross, Ashley Roselle, Chase Sanders, Hunter Cypress, Megan Thompson, Scott Turpin, Preston Young, Sarah Yoder, and Taylor James at the high school office.
Alright, nitrogenous base. So, there's 2 different types. There's purines, which are actually a little bit bigger bases, and then there's the pyrimidines, which are a little bit smaller. So once again, I'm going to go back to that picture, okay? You guys see on the A here, see how it has 2 rings to it, basically? It's a little bit bigger. And then, so those are the purines, the A's and the G's. And then the pyrimidines are the T, the C, and then in RNA it has a different one called uracil. Okay, so we're going to get to all that this chapter. Alright, so those are nitrogenous bases. And then you've got DNA. It's a pretty long one. You don't have to write all of it. You can just put the stuff that makes most sense to you. Organic acid and polymer composed of 4 nitrogenous bases. That might be easier.
So all we have to put it in the first 2 lines?
If you think that will help you to remember, the whole thing is on there for the quiz, but or the genetic material of most organisms, or that it's a double-stranded molecule, just a little bit of both.
Sorry for the interruption. I need to see Alex Morris, Daniel Kirkendall, Brett Jones, Jessica Wheeler, Susie Wheeler, Dylan and Dennis Powell, Dylan Pfeiffer, Christian Palmer, Clayton Nye, and Sierra McGill. Thank you.
The DNA, basically, it's a nucleic acid, right? We learned a little bit about those already, but DNA has 4 nitrogenous bases. It has A, G, C, and T. That's what those are: adenine, thymine, cytosine, and guanine. And DNA, as you guys know, is genetic material for most organisms. It contains your code. It contains all of the instructions to make you. Okay? DNA is double-stranded, and it's going to be helped gather by hydrogen law. Okay. Everybody good on this one? All right. This one is called molecular biology. A little bit shorter. It's a study of the biochemical and molecular interactions within living cells.
Teachers, I'm sorry. Any of the students that just came in and actually picked their announcements up directly from me in the office this Lindsay, and your box had a VT on it next to the amount, would you please come back to the office?
What gives me off of, was it a senior what?
Their announcements, their graduation announcements are in, I guess. So, we've all got to know who hasn't picked them up. Molecular, oh sorry, it's not very bright, is it? Molecular. I'll just make it a brighter color. How about that?
Well, it's on the same color.
Can you read it now? That's what counts. We'll go with that.
I mean, you could put like a new white box behind it and keep the same blue, but then you have to change the light.
I could.
What's the thing on the top here that's there?
That's a tag. Sorry. That's, how to explain it? A tag to kind of keep track of which mouse they're studying. Can you see it now?
Maybe a little more to the right. Halfway. That doesn't look like it now, but.
Oh, with their little teeth? A pterodactyl. You have some pretty skinny legs for a pterodactyl, I guess. Alright. Anyway, this is a mouse. Alright. And basically molecular biology, you know, we've been talking about cellular level, right? We've been talking about, you know, things like that. Well, we're going to get even smaller. What are some things that are smaller than a cell? Okay. Don't go that far yet. But you're right. What's a little bit smaller than a cell? What makes up cells? What are those little things that work together? Organelles. And then organelles are made up of molecules, okay? DNA and RNA are some of those molecules that we're going to find inside there, okay? So, anyway, this is kind of, this whole chapter is about how all this stuff works together.
Does that rat have like a staple in it, like a razor blade? What is that?
This, it's a tag to know which one it is.
Okay, never mind. Didn't know exactly.
It's okay. So we have molecular biology, and then we also have molecular genetics, okay? Molecular genetics, branch of genetics, dealing, well, hopefully that'll help you anyway. Genetics has it in the word. But dealing with the expression of genes by studying DNA sequence of chromosomes. Andrew, you got this one? All right, so all of you guys, or not all of you, but most of you that had, genetic disorder dealing with particular gene. Remember how, it said, oh, it affects this gene or whatever. And there's a deformity in that gene, right? And so then what happens is maybe that protein isn't being made, or that, there's a lot of things that can happen. But basically, when you choose a career in molecular genetics, you're figuring out which of those genes are faulty, which gene isn't working, and how does that affect, this person to create this sort of disease or this disorder. So it's, I don't know, if genetics is something that kind of interests you, this could definitely be a career for you. So the expression of genes, how each of these genes have a role and how they, play that role. And then you could also, figure out, well, what happens when those genes, when something's wrong with it. So, okay. All right, then we have the other nucleic acid called RNA. Ribonucleic acid. So this one's also an organic acid, so hopefully you put more than that for DNA. This one, RNA, is just a single strand of nucleotides. And the job of RNA is that it's a messenger between DNA and the ribosomes. You guys remember what the ribosomes do? It's been a while.
You do ribosomes steadily.
They do ribosome stuff. They make protein. Remember that?
So how do you sum down RNA?
I would put single strand, and I'd also put that it's a messenger between DNA and the ribosomes. And then it has a different base than DNA does. DNA had A, C, G, and T. Well, RNA has A, G, C, and U. So you could just put those letters, has the bases A, G, C, and U, maybe. Instead of writing out the whole word, you could just put the first letter, A, G, C, and U. Those are the bases that make up RNA. Okay, so RNA is single-stranded versus double-stranded.
DNA is double-stranded.
Mm-hmm. Everybody good on this one? Okay. This next term is called transcription, and this is a short one. Process in which RNA is made from DNA.
This
Process by which RNA is made from DNA. So if you remember just a second ago, we said RNA is going to be basically a messenger between the DNA and the ribosomes. So DNA are these strands on the outside, and what happens is RNA is made right from DNA, and this process is called transcription. And we'll get into all this and how it works. But anyway, so RNA is really a copy of DNA. Then we add the term translation. So we had transcription, and now we have translation. To translate something, it's converting, in this case, the genetic code from RNA into the amino acids that make up a protein. So basically, this strand right here is RNA, and it's a copy of the DNA. And then what happens is we read this code 3 letters at a time. Every 3 letters is going to code for an amino acid. All right? Amino acids link together to make proteins. All those disorders you guys just talked about were proteins that were defective, right? Proteins, usually. Except for Savannah's, really, is the only one I can think of right now that's not. So, anyway, this is the process of how we use that code to make these proteins. So it's pretty important stuff. And then we have the term mutation. An alteration, which is a change, basically, in DNA structure or sequence of a gene.
How would you get a mutation?
There's different ways, of course, but sometimes it can be the environment, radiation, and that's what happens with our DNA, and that's why cancer, okay, get that kind of mutation. Sometimes what happens is when they're copying the DNA, they put the wrong base paired with the wrong one. Your DNA, can do that. It doesn't happen very often, but it can. Okay. What number is that? That's a long one. All right, deletion. Chromosome abnormality in which part of the chromosome is missing, and that's probably all of it right there. So sometimes part of your DNA, part of your chromosome is broke off. Well, in this little segment right here, there's important genes that your body needs or that you need. And so what happens is when that's deleted, we can't make those genes. So sometimes we have that problem as well, and that can create some problems, some genetic disorders or something too. All right, we'll stop with that one. That's 12, right? So we'll have 3 more to do tomorrow morning. Christian, Eric, Seth. Okay, you guys will be first thing. So make sure it's ready. Eric, did you upload yours? Well, how am I going to get it?
Last period is what I checked. At the end of the period.
Okay.